Good morning, students. First, let me introduce myself. My name is Vishnu. I'll be your new maths teacher. And today I'm going to start with a new chapter, algebraic expressions. Okay, to understand the first exercise, we have to understand what is variables, what is coefficient and what is terms. Okay, so let's start with what is variables. Let's say in real life we have a lot of examples like pen, pencils or any other object. But in mathematical terms, when we put them in mathematical terms, we can't use those terms. So instead, we use a very short forms of words which we call as variables. So basically variables represent bigger names, okay? Like we can use X, Y, Z. This represents certain objects of real life, and the value of variables are never fixed. Although the constant values like 4, 5, 6, these are like constant numbers. Okay, these are constants. These are never going to be changed. These are fixed, but the variables always change depending upon the situations. Now let's say a certain person goes and buys let's say 10 hippopotamus and 20 elephants and 30 giraffes. So now you can't put all those things just like that and do a mathematical addition. So there we use certain variables. We can assume the hippopotamus as X, we can assume the elephants as Y, we can assume the giraffes as Z, and we can do a simple addition. The complexities will reduce when we use variables. Okay. So now I hope you have understood what is variables. Now let us look at coefficients. So let's say I write 7x. Now you know x is a variable. It may represent anything, okay, pen, pencil or anything depending upon the question. But the 7 here represents coefficient. This is our coefficient. So if I ask you what is the coefficient of x, your answer should be 7. So let's say I write 17x square. Now if I ask you what is the coefficient of x square, your answer should be 17. Let's say now if I ask you what is the coefficient of x square, your answer should be minus 7y. This entirely is the coefficient of x square. Okay, although y is also variable, but if I ask you what is the coefficient of x square, this entirely is the coefficient of x square. So if I ask you what is the coefficient of xz, the answer is minus 8. Okay. So I hope you have understood what is coefficient. Now let us look at terms. See, in this class we are going to study 3 types of terms. Okay. First is monomial, second is binomial, third is trinomial. Okay, so three types of terms: monomial, binomial and trinomial. Okay, so let us understand what is monomial. Let's say if I wrote 7 1. As you can see here, there is only one term. ஒரே ஒரு term ever. There is one term. So when there is only one term, we say it's monomial. We say it's monomial. Mono means one. Mono means one. Meal means term. So one term. Okay. So let us say 3x z. This is still monomial. If I wrote just 5, even though this is a constant, this is also monomial. Okay, I hope you have understood what is monomial. Let us look at what is binomial. Bino represents 2. Meal means terms. So if there is 2 terms, we say it's binomial. So let us say 7x plus 5. This is one term, this is one term. Total there are 2 terms. So we say this is binomial. Let's see one more example. This is one variable, this is another variable, and this is one term, this is one more term. So total we have 2 terms here. Okay, so this is also an example of binomial. But if I add one more term constant, now it has become different. It's not binomial anymore. Okay, so only this much is binomial. Now let us look at trinomial. Tri means 3. Okay, trino means 3 and real means terms. So 3 terms are there. So let's say 7x plus 3y plus 4xy. This is one example of trinomial. There are 3 terms, 1, 2, 3. Now let us look at one more example. Now there are 3 terms. This is one term, 2x square. This is another term, 5xy. This is another term, 6. So there are 3 terms now. So this is also an example of trinomial. But if we add something else, if we add even a different number, let's say if we add 5, because 6 and 5 we can add and make it as 11. This is still going to be trinomial only. But if you add some other number, like some other variable other than x square, 5xy, if you add any other variable, like if you add y, now it has become polynomial. That's a different thing. Okay, now it's not trinomial anymore. Okay, now you have to understand in variables like terms. This is very, very important, like terms. Okay, so remember this one thing very clearly. X and x square are two different types of variables. Y and y cube are 2 different types of variables. X square, x cube, x to the power 4, all are different. All are completely different. They are not same. Okay. So when do we call them like terms? See, let's say I have a variable here. Let's say 5x. If I have another variable, let's say 6x. Now these two are like terms. So when we talk about like terms, we can always do an addition of like terms or subtraction of like terms. So 5x plus 6x gives us 11x. or we can subtract them also. We can subtract them also. We can do 6x minus 5x gives 1x. This is also possible. Okay. We will not talk about multiplication for now, or division of variables. We will only talk about addition or subtraction of like terms. Okay. So to identify like terms, always make sure. Always make sure the power should be same. The power should be same. See here. Here the power is 1. Even though I wrote just x, the power is 1. Here the power is clearly mentioned 2. So these two are different. Okay? These two are different. These two are not like terms. These two are not like terms. The power should be same and the variables should be same. So if I introduce here xy, and here also I have introduced xy, here it's xy square and here it's x square y. See here, the power of x is here is 1, here the power of x is 2. So these two are not like terms. These two are not like terms. So if I gave you a question, x to the power xy square 3xy square plus 2x square y, and if I ask you to do addition, remember you can't do addition. Because these two variables are completely different. They are not same. So to identify like terms, make sure you look at the variables and then you have to look at the power also. The power should also be same. Okay, now let us look here. 6x square y z plus 2x square y z. Now look at the variables x, y, z. Look at the power x square, y power 1, y power 1, z power 1, z power 1. Okay, so these two are completely like terms. So when they are like terms, we can do addition. So 6 plus 2 is how much? 6 plus 2 is how much? 8. Then you have to write x square, y and z. There should be no change in the variable. Now to understand this in a very simple way, assume there is a room and in that room you have 10 cats, and then let's say you have another 20 cats. If I ask you how many cats are there in the room, you would say, so total 30 cats are there. You will not say there are 30 dogs. So similar way, when you do variable addition, make sure you write whatever the variables is given as it is. There should not be any change. You can't put the 2 here. That will give you a wrong answer. You have to keep the variable as it is with the same power and just do addition of numbers. Okay, so if I give you the same question and I ask you to subtract, then remember 6 minus 2, 4. Keep the x square, y and z as it is. Okay. Okay. So now you know what is like terms, so you automatically know what is unlike terms also. What is unlike terms? Whichever term is not like terms, we call them unlike terms. Let's say 5x, 11x are like terms. So instead of x, if I put x square, these are not like terms. These are not like terms. These three are not like terms. These are unlike terms. So when they are not like terms, we call them unlike terms. Now look at, take exercise 12.1, page number 235. Question number 4. Identify terms which contain x and give the coefficient of x. So the first question in that is y square x plus y. So in that, identify terms. How many terms are there? That's the question. How many terms are there? Identify terms which contain x. Okay, which contain x and give the coefficient of x. Okay. So in that, identify the term which has x. X. That's the question. X is here. So what is the term? Y square x is the term with x. The second question is, if so, what is the, give the coefficient of x. X in the coefficient is always whatever is in front of that variable. Within the front row is y square. So here the coefficient is y square. This is the term y square x. Now let us look at fourth one of the same question, okay, which is 5 plus z plus zx. Now look here, identify terms which contain x. Tell me, where do you see x? X is here. So what is the term? This is the term. This is the term which has x. And the next thing is, give the coefficient of x. Coefficient of x is going to be z. Now look at question number 6. See, now what is the term with x? Which is the term with x? Term is going to be 12x y square. Now the coefficient might confuse you. See here, the term in front of x is 12. But remember this one thing. We can write 12xy square as 12yx square also. We can write this as 12yx square also. So now look here, the coefficient in front of x is going to be 12y. Is going to be 12y. y square, sorry, 12y square, because it's y square. Okay. Yes. Now I hope you have understood exercise 12.1 question number 4. You are able to understand the terms and coefficient. Now look at the B section of the fourth question. The B section of the fourth question. In this, identify terms which contain y square and give the coefficient of y square. They have clearly asked the coefficient of y square. So this is the first one, 8 minus x y square. So which is the term with the term y square? which is the term which contains y square. This is the term. So this is the term. Remember, you have to include the sign also. Sign also you have to include. Now, when you include the coefficient, there also you have to include the sign. So the coefficient is in front of y square we have x, but we also have to include the sign. This is going to be minus x. This is going to be minus x. Now look at exercise 12.1, question number 5. Classify into monomial, binomial and trinomial. The first one, 4y minus 7z. There are two terms clearly we can see, so this is going to be binomial. Next one, y square. This is only one term are there, so this is monomial. The next one is x plus y minus xy. There are three terms in that, so this is trinomial. The fourth one is just a constant, which is 100, so this is monomial. AB minus A minus B, this is there are three terms are there, so this is going to be trinomial. I am sure you will be able to do all the other questions. It's very easy. Now look at question number 6. State whether a given pair of term is of like or unlike terms. Very, very important. So the first one is 1 and 100. The first one is 1 and 100. 1 and 100. So these are both constants, and I have already told you we can always do addition of constant, and constants are like terms. So 1 plus 100. Just see 101, we will get 101. So this is like terms. Now let us look at the second one, which is minus 7x, comma 5 by 2x. Just look at the variable and its power. Variable is x, variable is x. Power is 1. If nothing is given, it's always 1. Power is 1. So both are like terms. Okay, so this is also like terms. Next, look at the third one. Minus 29x, comma, minus 29y. Now see, although their coefficients are same, here the variable is x, here the variable is y. So these are completely unlike terms. Although the coefficient is same. This is 29, minus 29, this is minus 29, they are same, but because the numbers are same, they are not like terms. It should be the variable and their power. Here the variable is y, here the variable is x, so they are completely different. They are not like terms, they are unlike terms. Now look at the fourth one. It's quite interesting. 14xy, comma 42yx. See here the variable is xy, here the variable is yx. I am sure you will know 3 into 2 is going to be 6 and 2 into 3 is still going to be 6. Is there any difference? 3 into 2 is 6, 2 into 3 is 6. Both are same. So x into y. Similarly, x into y is xy. Y into x, you can write it as xy or you can write it as yx. This also you can write it as xy or you can write it as yx. So xy and this is also xy only. So the powers, the variable is same and their power is 1, here 1, here 1, here 1, here 1. So because the power and the variable are same, we can say these are like terms. Now if you do an addition of this, we will get how much? How much will we get if we do addition of this like terms? We will get 6 and I think 56, 4 plus 2, 6, 5, 56xy. This will be our answer. Okay. Now look at this one, fifth one. 4 m square p and 4 mp square. See, the variable is mp, but now look at the power. Here the power of m is 1, here the power of m is 2. So is it same? Is it like terms? No, it's not like terms. These are unlike terms. Okay, these are unlike terms. Now look at the sixth one. 12 xz, and then we will have 12 x square and z square. See, although the variables are same, here, the power is, here power of x is 1, here the power of x is 1. So these are not like terms, these are unlike terms. Now look at question number 7. Identify like terms in the following. It's a very lengthy expression, minus x square. Let me do the first one alone. Of 7, okay. So the first term is minus x y square. The second term is minus 4 y x square. The third term is 8 x square. Well, now I can't use the entire board for this, okay? So let's see, let's find out the like terms first. Xy square. Just look for xy. Here xy is there, but the power is different, so this is not like term. Here xy is there, here xy square, here xy square. So these two are like terms. These two are like terms. Now let us look at one. If any other xy square is there, here no, it's different, here xy only. This is x square y, this is y x square, but we can say it as x square y also. Here x square y is there. So these two are like terms. Now let us look for x square. Here 8x square is there, here minus 11x square. So this is one like term. Now let's look for y. Here 7y is there, any other y is there, here 1y is there. So this and this one like term. Okay, and let's look for x. Here minus 100x, here 3x. So these two are one like term. Here minus 11yx, here 2xy. xy, yx, xy. Both are same only, okay? So these two are one like term. Anything missing, no? Yes. See here, 8x square and minus 11x square are like terms. Similar way, this is also like term. This three. 8x square, minus 11x square and minus 6x square are like terms. Okay, so in x square has three like terms. Okay. So I hope you have understood the like terms also. I can't utilize the whole board unfortunately. The question unknown is bit lengthy, that's why. Okay. Now let's look at the addition and subtraction of algebraic expression. I have already given you some hint of when we can do addition and subtraction. It has to be like term. It has to be like term. Only like terms can be added and only like terms can be subtracted. Okay. Okay, let me write one example. Let me do one example question for you. So example number 4 says, page number 238, okay. Example 4, collect like terms and simplify the expression. Collect the like terms and then simplify the expression. So the term is 12m square minus 9m plus 5m minus 4m square minus 7m plus 10. So this is the term that is given here. Okay, this is the entire expression. Now in that we have to find the like terms. So let's start with collecting the like terms. So this is one like term, this two and this is one like term, and then we are left with one constant value which is 10. So let's bring the like terms together. 12m square minus 4m square minus 9m plus 5m minus 7m plus 10. Okay, so here in the book they have taken constant. So here 12m square, here m square is here, m square here also is there. So we can take m square as constant. We can take m square as constant, and then we can just subtract the numbers. Here also we can take m as constant. Here 9m, here 5m. So m as constant. Okay, so when we take m as constant, we will get here, we will do one thing, keep it as plus, we are taking m as constant. Instead we will get minus 9. Here we will get plus 5. And here we will have minus 7 plus 10. Okay, so if we solve here, we will get 12 minus 4, 8. 8 plus, keep them as it is. Here we get minus 9 plus 5. So when plus and minus comes, what we do is we do subtraction. We do subtraction and we put the sign of the greater number. So 9 minus 5 is 4, and which is the greater here? 9 is greater, and what is the sign of 9? Minus. So the answer is minus 4 and then minus 7. Keep that as it is. Plus 10. Okay, the next step here we will get 8 into m square is 8m square. Here we have to solve further. We will get here minus 4 and minus 7. When minus and minus comes together, when the sign is minus and minus, we do addition of number and we put the sign of minus. So minus 4 and minus 7, addition of number, do addition of number. Addition of number is how much? 7 plus 4 is how much? 11. But you have to put the sign of minus. So we will get minus 11 plus 10. plus 10. Let me rub here and it's very small board, so right here. Okay. So here I got 8m square m into minus 11. So this minus 11 will come out and becomes minus 11m plus 10. So I think we have got our answer. This is our answer. Here, instead of taking common outside, you can simply do addition or subtraction. So if you see here, 12m square minus 4m square, you can directly write 8m square also. That's not a problem. Okay. But when you do here, be careful, otherwise you will make some mistakes. Minus 9m plus 5m gives minus 4m. Minus 4m and minus 7m gives minus 11m. So if that way also you can solve, it's much faster. But if you make some mistakes using when you are doing with sign, then you will get a wrong answer. Okay. So now here, now look at example number 5. Subtract 24ab minus 10b minus 18a from 30ab, 12b, and so when we say subtract 5 from 10, that means if we write it in the short form or column form, we have to write that 10 on top and 5 below. This is how it is done. Okay. Now, when I say subtract 5 from 10, you have to write 10 first. Then whatever we have to subtract, you have to write it later. After that. Okay. So here also we have to be very careful. It says very clearly subtract 24ab minus 10b minus 18a from 30ab plus 12b plus 14a. So this 30ab plus 12b plus 14a has to be written first. Then consider them as one term, okay? Then you have to put the sign, which is minus. And then the next term, which is 24ab minus 10b minus 18a. Now remember this one thing, because of this one sign which is minus, if you write it in a one single line, I can show you much better what happens here. Here. Now, because of this one minus sign, the entire sign which is inside the bracket will change. Okay, the entire, you have to take them in bracket. Well, they won't give in the, nobody gives in the question paper bracket. They will just say subtract 24ab minus 10b from minus 18a from so and so. So we have to take them in brackets. Now what is the reason? See here, this minus, because of this minus sign, the sign which is inside, will change. So minus becomes positive, positive becomes negative. That's how it works. So let me expand it one time. 30AB plus 12B plus 14A is going to be same. There will be no change in this sign. But because of this minus, when we open the bracket, this will become minus 12B4AB. This minus will become plus 10B. And this minus will become plus 18A. Now, first step is to keep them in bracket. Second step is to open the bracket. But when you open the bracket, change the sign. Remember that. Now, see here. Identify the like terms. 30AB minus 24AB. This is one like term. 12B, 10B. This is one like term. 14A, 18A. This is one like term. So we will bring the like terms together. Okay, see here, 30AB minus 24AB is how much? It's like you have 30 apples and you eat 24 apples. How many apples are left? 6 apples. So 6AB plus you have 12 apples with you and then you got another 10 apples. Then it becomes total how many apples? 22 apples. So 22B. Plus 14A plus 18A. So how much it is? 32. Okay. So the final answer is 6AB plus 22B plus 32A. This is our final answer. Okay, now let us look at exercise 12.2. Okay, first simplify combining like terms. Okay, so in this we are going to do the question number 3. Question number 3. First in a 3. So 3 says P minus Q minus Q minus Q minus P. See, I already told you, because of the sign minus, if the sign of the variables which is in the bracket will change. So because of this minus, this sign will change. Here it will change, here also it will change. Because of this minus, this sign will change and this sign will change. Now the P is plus. When we open the bracket, P becomes minus. This minus will become plus. This is going to be same, but this sign will change. Here it will become minus Q, here it will become plus P. Now we have to bring the like terms together. See, this is plus P, this is minus P. So this is plus Q, it's minus Q. We can cut this one. And we are left with minus Q plus P. We can write them as P minus Q. This is our final answer. Okay. Now let's look at question number 6 of the first one. Y square plus 5y minus 4 See here, same rule we have to follow here also. 3y square plus 5y minus 4 is going to be same. Here it will become minus 8y. This will become plus y square. This will become plus 4. Once we open the bracket. And then bring the like terms together. This is one like term. This is one like term. This is one like term. So 3y square plus y square becomes 4y square plus 5y minus 8y. See, plus 5y minus 8y. Plus and minus, when it comes together, we have to do subtraction and then we have to put the sign of the greater number. Here, if we subtract 8y minus 5y, we get 3y. We get 3y. But 8y has a greater sign, which 8y is 8 is greater than 5 and its sign is minus. So we will put minus 3y. Next, plus minus 4 plus 4. Minus 4 plus 4. Both will become 0. So the answer is 4y square plus 3y. Ma'am? Ma'am? Okay. So students, that's all for today. Have a nice day.